All right, so here we are with the follow-up to our data collection. So you know the numbers, and if you had your sheet out, you probably wrote them down. But now we're going to look at how we're going to calculate a few of these things. They're real easy. It's just when you first hear them, they sound complicated. Like, if you know what your tidal volume is and you know your respiratory rate, then you know your minute ventilation rate, because it's just one times the other. It's like heart rate times stroke volume gives you your cardiac output per minute. So we're looking to see how much air you moved in and out of your mouth in a minute, and then we're going to see how much went in and out of your alveoli in a minute. All you have to do is take off the dead space each breath, because that's the part that didn't go in. So once you know how big you're breathing and how fast you're breathing, multiply those together and you'll get minute ventilation. If you take off the dead space, then you get your alveolar ventilation, because that will tell you what went in after the dead space didn't. So we have a couple of things. First of all, we had our predicted vital capacity. Okay, this is backwards again. The camera does that so that my left and my right are correct instead of being reversed like they are in a mirror, but it makes the words backwards on paper. So there's nothing I can do about it. I haven't, even online, nobody will tell me a way to reverse that. So anyway, predicted vital capacity, we said was 4.4 liters. And we did that by doing those calculations, 0.052 times height and whatever times age and minus 3.6 and so forth. So we had that. My predicted dead space, how would you do that? Well, if it were a test question, I would give you some data about myself, and one thing would say that I weigh 195 pounds. Well, guess what your predicted dead space is? 195 milliliters, because it's 195 milliliters, because it's approximately a milliliter per pound of body weight. The tidal volume, we said, was a half liter. So let's go 500 mLs. It makes it easy to do it that way. 500 mLs. It's backwards, but you can read backwards. Our IRV, inspired reserve, was 3.9 liters, which is 3,900 mLs. Expired reserve was 0.83, which is 830 mLs. Remember, there are 1,000 milliliters in a liter. Our vital capacity, we added it up. You add those three guys, and your vital capacity is what you get. So it was 5.2 liters, or 5,200 mLs. Okay? So you have your tidal volume, IRV, ERV, those three give you your vital capacity. Wonderful. Now, there are a couple of other numbers that you will need to do the rest of the calculation. One is the respiratory rate. Well, we said our respiratory rate was going to be 12 breaths per minute, BPM, 12 breaths per minute. And that's what I said on this sheet anyway. I said we're going to use 12. So I might as well be consistent. Residual volume. You can measure residual volume through a fairly complicated process of breathing pure nitrogen and seeing how much air it displaces and so forth in your lungs. But for the purposes of this, we're going to say, yeah, people have a residual volume of about a liter. So when I blow out as much air as I can possibly blow out, I still have about a liter of air left in my lungs. They don't collapse. So my residual volume is about 1 liter, or 1,000 mLs. So what if I wanted to calculate my total lung capacity? What is total lung capacity? Well, it's your vital capacity, that's the air you can move, plus your residual volume, the air you can't. So all you'd have to do is add another liter. So 5.2 liters was my vital capacity. TLC TLC, total lung capacity, would include the residual volume. So it would be 6.2 liters. 6.2. Now I know people, when I start using numbers, about half the class almost has a heart attack because it's math. This isn't math. This is second grade arithmetic. 5.2 times plus 1 is not math. All you have to do is know what the numbers are, and you can figure out what to add together. 300 plus 3,900 plus 830 is pretty easy to add, especially if you get to use a calculator on the test. But even if you don't, you can add those numbers. You add another liter, you get total lung capacity. So don't get freaked out by the fact that there are numbers involved. These are simply relationships between lung volumes that you need to know. It's not the ability to do math. All right, so now we have to do pulmonary ventilation. Pulmonary ventilation is what? It's how much air you're moving in and out of your lungs every minute. And all that is your tidal volume, that's your breath size, times your respiratory rate. If I'm breathing in a half liter per breath and I'm breathing in 12 times, what am I breathing in and out of my mouth every minute? Okay, 6 liters per minute. Okay, 6 liters per minute, 500 mLs times 12, or a half liter times 12 breaths per total breaths, give me 6 liters. So my pulmonary ventilation is 6 liters. The only one here that gives people a little problem is, what about alveolar ventilation? Well, all you have to do is subtract out the dead space each time. So you would go 500 mLs, which is my tidal volume, 500 minus 195, and I'm going to do another way here. So okay, yeah, that should be about right. Okay, I thought I was doing something wrong. Is 305 mLs. Okay, so if each breath I'm taking is 500 mLs, but 195 is not making it into the alveoli, then the rest is. 305 mLs is making it into my alveoli with every breath. With every breath. So I have 12 breaths a minute, 12 breaths, 305 times 12 times 12 equals 3660. 3660 mLs per minute, or 3.66 liters per minute. Now, this is going to seem confusing to you at first, but make up some numbers and do it over and over again until it becomes easy. To get minute ventilation, you simply take your tidal volume and multiply it by your respiratory rate. 500 mLs times 12, or half a liter times 12. For your alveolar ventilation, you just take out the dead space and then multiply with what is left over by 12. So 500 minus your dead space times 12. Now on the test, you'll have something like this. It'll have your person's weight. It will give you their tidal volume. It'll give them the respiratory rate. It'll give you, all you have to do is say this times this equals minute ventilation. This minus this times this gives you your alveolar ventilation. Okay, so again, practice that. There's no reason to get this wrong on the test. It's very straightforward, but you have to do it enough times that you don't get the numbers in the wrong place or something when you're taking the test. Now, we got the FEV1, remember, it was about 70%. So you could write that on there somewhere too, FEV1 70%, which is a little bit low. It's supposed to be 80%. So that was another number that would be useful to us. Here is the typical flow chart, okay? You blow as hard as you can, you reach your peak expiratory flow, and then the expiration starts decreasing as the airways compress, and then you suck all the air back in, okay? Your peak expiratory flow is at the peak. My peak expiratory flow was 5.74 liters per second, which is almost 6, which is at the higher end of normal for somebody my size and stuff. So that's okay too. The only number I had that was slightly low was the FEV1, perhaps because I didn't calculate it. I mean, pick the numbers exactly right, or perhaps because there's a little bit of a pollen deal going on out here. So that should be everything. You should understand how a pulmonary function test works. You should understand the numbers you get. Your tidal volume, your inspired and expired reserve, that's your vital capacity. Add the residual volume, you have total lung capacity. Multiply your tidal volume times your respiratory rate to get ventilation, and subtract the dead space each time. So tidal volume minus dead space times respiratory rate will give you alveolar ventilation. Know what the PEF means and about the right range it should be, and know the FEV1 range about what that should be. And that'll get you pretty far on this kind of question that will show up on the test.